So now I want to talk about the density-driven and the wind-driven components of the circulation. We mean the horizontal flows, not the tides, not the wind waves, the general circulation which takes place on timescales of days to weeks to months. Okay? And in order to do that, because it's relatively tricky to do that in terms of field observations, you can use satellite images of sea surface temperature if you like, but it doesn't show you the key features of the circulation, which is actually related to salinity differences. In order to see that, I want to show you simulations, predictions by a hydrodynamic model, a computer-based model. And this is how these models are configured. They're sort of configured in terms of grid cells or grid boxes. And in the model, it works out the forces that create the currents that move temperatures anomalies, salinity anomalies through the faces of these boxes. You have a shape of the sea surface, which creates pressure gradient. Again, accelerating currents, decelerating currents. You have, okay, and that, just start here from the top. So you're looking at grid cells in 3 dimensions, and this model uses a relatively coarse horizontal grid, 3-kilometer grid spacing, and 10 layers in the vertical. And that's what we call a sigma coordinate model. It has 10 layers, and if you have your sloping bathymetry, you can see that the grid that you use actually is adjusted to the shape of the seafloor. Okay, and relatively coarse again, so that we're able to actually simulate do a multi-year simulation. Simulation time is 5 years, and the model includes tides. Tides are prescribed at the boundaries, lateral boundaries, and predicted in the inside of the model domain. Has a wind forcing, a surface wind forcing, and it has also heat fluxes and precipitation and evaporation, which changes the temperature and the salinity. And then it's calibrated against observed tides and temperature salinity. So calibration means you have the main parameter that you can adjust is actually bottom friction. How strong the bottom friction is plays a big role in the circulation that you have. Anyway, I don't want to talk that much. I want to show you first the calibration, and then I want to show you a bunch of simulation results.